Hello, my name is Jesse Bacci. I'm a project manager here at DMC, and this is my FedEx Day project. It is a 32-channel custom relay circuit board made for switching connections in automated test applications. FedEx Day is a tradition that we've started at DMC over the past couple of years, where we will periodically have a day where the entire office takes a break from our normal project work and spends time working on projects that have a benefit to DMC or are sort of fun projects that are engineering and technically related projects that are just cool applications of the technology that we normally work on here at DMC. And the reason it's called a FedEx Day project is because we have to deliver something the next day, like a FedEx delivery, and have something to show and demonstrate from the previous day's progress to show to the rest of the company the next day. Here is the 32-channel custom relay switching printed circuit board that I put together for DMC's recent FedEx Day. What this circuit board provides is 32 independent relays that can be used for a wide variety of purposes in both automation as well as automated test and measurement applications that DMC works on. Just having the ability to switch connections in an automated fashion is extremely useful and powerful for, again, a wide variety of applications. This might be switching power on and off to a particular device. It might be taking one highly accurate and perhaps expensive instrument and having the ability to switch the connections of that instrument's probes to a variety of points that you might want to acquire measurements on. So this kind of multiplexing architecture makes it possible to design test stands that have really accurate instrumentation, but are cost effective because you can acquire all the measurements you need with just a smaller set of instruments. The goals of this were really just to put something together that would allow us to do this relay switching with some high electrical performance specifications, something that would be really easy to integrate into the platforms and stuff that we typically develop these automated test applications on. In most cases, that tends to be LabVIEW and using National Instruments hardware. I think we'll start with looking at the control of this system. And for this, I chose to go with a NI compact DAC chassis and to design the board to work with a C-series module that provides 32 syncing digital outputs. Basically, that means 32 channels where, based on software control, we can control these digital outputs to sync current from the given signal line to a common line. The board itself involves essentially 32 repeated circuits where each one consists of a relay and the corresponding circuitry needed to drive that relay. So if you kind of zoom in here, you'll see the same circuit element repeated a bunch of times on the board. And for each relay, there's essentially the relay itself. The board's designed so that the footprint, the holes and traces and everything that are laid out for the relay actually have holes for two different primary relay package footprints. So depending on the application, you could use a smaller relay that would just be more cost effective, or a larger one that would be useful if you needed to carry higher currents through your contacts of the relay. The whole thing is meant to be mounted in a panel where you would have the primary wiring scheme, the primary wiring architecture of the given test system application. And so the contacts of the relay are all routed out to terminal blocks. So now I'm going to go ahead and just give a simple demonstration of this board in operation to show you how it will function in the test system. And right here, simply running a very basic LabVIEW application that is toggling the digital output channels of the C-series module in the compact DAC chassis to toggle relays. It's doing so by randomly selecting a relay to toggle and toggling them at a random time interval with an average of 1 second right now. We have the ability to control the relays extremely quickly in software, and to do so using a platform that integrates really easily into any LabVIEW application, so we can use NI DAC-MX powerful hardware configuration kind of ability integrated into LabVIEW to give all of the channels that would drive our relays names, tangible names to describe their function or control them on a port basis. That's the goal. That was the goal of the board, to have something kind of generic that could be useful in many different automation applications, give high performance specifications, be cost effective, and easy to integrate into test systems.